Welcome to this lecture on process control. We are doing Laplace transform. So in this lecture, we will solve some numerical problems related to Laplace transform. Well, the question is this. The function is given f of t equal to u of t minus 2 into u of t minus 1 plus u into t minus 3. We have to sketch the following function. Of course, there is no Laplace transform directly involved in this. It's only in this case, it is only we are going to draw a sketch. So next lectures we'll see linear Laplace transform of also. So this is mainly about function. This problem is about a function and its sketch. Well, we know what is u of t. U of t is a unit step function. What does it mean? What are the values of unit step function? We have seen earlier in forcing functions. The value of u of t is equal to 1 for t greater than 0. At all values t greater than 0, the value of this function is 1. For t less than 0, the value of this function is 0. So u of t is 0 at t less than 0, and at t equal to 0 or greater than 0, it rises suddenly to 1. So this is the meaning of step function. Similarly, what is the meaning of u of this function like this, u of t minus 1? U of t minus a will be equal to 1. What is a? A is any positive constant, any positive integer or positive fraction. So a is a positive number, maybe a constant. It's a constant, maybe an integer or decimal or a fraction. So value of u of t minus a, u of t minus a is also a step function, unit step function, but its value equal to 1 for t greater than a. It's a shifted unit function. Translation of function. Function is translated into t minus a. It's a shifted step function. So the value of it is, for t greater than a, the value of this function is 1. And for t less than a, the value of this function is 0. So with this in mind, which we have discussed in the earlier lectures on forcing functions, step function. So let us plot this, let us sketch this curve. So first one is unit step function starting from 0. 0 I taken here. For clarity, I shifted 0 on the x-axis here. So it's a unit step function. It rises from 0 to 1. It's a vertical, okay? Please treat it as vertical. Okay, at 0, it rises from 0 to 1. Then it remains at 1 till t equal to 1 here. This is 1. This is 0. Then at 1, there is a minus sign of magnitude 2. So there is a step function in the decreasing direction of magnitude 2. So it decreases, step function, all vertical and horizontal lines. So this is 1, this is 0, and this is minus 1. So first rises from 0 to 1 at 0, that is this. Then next, from this, there is a decrease of magnitude 2. Another step function of magnitude 2 is decreasing from this. So magnitude 2 decreasing direction. So it goes like this till t equal to 3. And at t equal to 3, it gathers a magnitude of plus 1. It increases by plus 1, plus ut, plus of u of t minus 3. This minus 3 is, it happens at 3 plus 1 u, magnitude of 1, unit step. So this is 3. So this is 1, somewhere here will be 2, and this is 3. So this is our function. This function is this. So this is u of t, and this is 2u minus 2 u of t minus 1, this one. and this remains like this, and at t equal to 3 it raises by 1 magnitude. So this is the sketch for this. So let me give you a neat figure. This all, imagine this all, you should imagine this to be all verticals and horizontals, perfect verticals and perfect horizontals. Let me try to give a neat diagram of the same thing. Well, here is a diagram. This is u of t here. U of t. This is u of t rising from 0 to 1. This is u of t. Then at t equal to 1 here, it decreases with a magnitude of 2. With a magnitude of 2. So it's a downwards graph because of minus sign. So downwards step function. So it remains like that up to 3. And at 3 what happens is another unit step function. That is step function of magnitude 1 is added to this. So it becomes like this. And afterwards, so net value is, if you see the net value, at after 3 it has to be 0. If you see the value for any value t greater than 3, okay, let me write for t, first let me write for t greater than 1, but less than, sorry, t less than, t greater than 0 but less than 1. So if you take t greater than 0 but less than 1, only this value will be there, only u of t will be there, only this, all other values of 0, this is 0, this is 0. So for t between 0 and 1, here the value is 1. Okay, now if you take t between 1 and 2, if you take between value of t between 1 and 2, that is when t lies between 1 and 2, what will be the value? T less than 2, only the first and second terms will be there. So this will be 1 minus 2 equal to minus 1. So between t1 and 2, the value will be minus 1. Yes, this is the value, minus 1 here. So anyway, this will hold good. This will be applicable till not only t less than 2 but till t less than 3. Up to t3 this will hold good, because only when t equal to 3 this function comes into picture. The third function comes into picture only when t equal to 3 or more. So if t is between, when t is greater than 3, what will be the value? So when t is greater than 3, let us substitute the values here. For t greater than 3, every function will be 1. For t greater than 3, all the three functions will be 1. 1 minus 2 plus 1. So this is going to be 0. For t greater than 3, the value of the function is 0. So that is why here it is 0 here. Okay. So for t between 0 and 1, the value of the function is 1. For t between 1 and 3, for t between 1 and 3, the value of the function is minus 1. This is for t1 and 3. For t between 1 and 3, for this value, it is minus 1 here. Between 1 and 3, the value of the function is minus 1. For t greater than 3, the value of the function is 0. So this is the concept of units in step functions, addition and subtraction, etc. So I hope you had understood this concept. We'll come with more worked examples in the subsequent lectures. See you.